And so isotopes are nothing but forms of elements. So what I said, we can count the elements with our fingers, so that means they are only limited. But when we go in depth, like when we compare with all 118 elements, okay. So when we compare with all 118 elements, okay. So with this 118 elements, so we like 1 to 30 elements according to your standard. 1 to 30 elements. That means all these 1 to 30 elements we'll observe in general around us. Okay. In view with the 30 elements, we can count the isotopes with our fingers. When we compared that huge number like 118 elements, so most of the artificial elements will be having this forms of isotopes, and even above 30 elements also, some elements will undergo with this isotopes. Isotopes are nothing but forms of elements. It's not compulsory to learn all the isotopes of all 118 elements or less than one, more than 100 elements are undergoing with this isotopes. But what are the elements which are used to us in our day-to-day life? Like simply we can say the general isotopes. Understood? In general isotopes, like within that 118 elements, there are few isotopes which are used in our everyday life. Or the only thing you are going to learn, that means what are isotopes? What are isotopes? What are the few isotopes which are used in our day-to-day life? What property does this isotopes have? How are they formed?
Yes.
Okay. So isotopes means elements having same atomic number but different in mass number. Elements having same atomic number but difference in mass number. Okay, this is nothing but isotopes. Understood? Yes or no? So what do you mean by mass number? That also we have discussed in the last session. What do you mean by mass number? So when we represent a complete element, so how to represent the complete element with this? So before to write isotopes, we should know the representing of example E is the element. Okay, we write the atomic number at the subscript, and we write the mass number at the superscript. This is the complete representation of the element. If you are very much clear about the atomic number and if you are very much clear about the mass number, then we can represent the element in this form. This is the complete presentation of element. Understood? Yes or no? So Z is nothing but atomic number. Who gave the concept about the atomic number, children? A is mass number. Who gave the concept of atomic number? Atomic number.
Henry Moseley.
Henry
Moseley.
Henry Moseley gave the concept about the atomic number. Atomic number is Z. A is nothing but the mass number. Understood? So this is the complete representation of the element. So how to write the mass number? How to write the mass number, children? So as what we are learning now in your standard 8, the same concepts, or these are the fundamental basis, are the same concepts you are going to mass number. Mass number is equal to the sum of number of protons plus
Ma'am, mass number is the number of protons and neutrons present in a nucleus.
of an element. So mass element is nothing but number of protons plus number of neutrons. Yes, correct, Akshay. What you said is correct. Akshay called it?
Yes, ma'am.
Okay, for example, if you consider carbon atomic number 6. Carbon atomic number 6. In general, if you see, yes, in general, if you see, the number of protons, electrons, neutrons, all the three are same. If we compare, for almost all the elements, especially element like hydrogen, it is having its unique property. Other than hydrogen, almost all the elements are having number of protons, neutrons, electrons are same. Only the exception is hydrogen. Why? Because in case of hydrogen, it is unique and it is present at the top of the periodic table and it is given as element 1. Element 1. Why? Because almost all the elements are having same number of protons, electrons and neutrons. Read about the isotopes. All are having same number of protons, electrons and neutrons. If we consider hydrogen, hydrogen is having 0 neutrons. Hydrogen is having 0 neutrons. Understood? When hydrogen is having 0 neutrons, so it is having atomic number 1 and mass number is also 1. Am I right? Atomic number 1, mass number, like number of neutrons 0, so 1. So hydrogen is having atomic number 1, mass number 1. So it is considered as unique and it has given the position top. And it has given, and there are, yes, very good. And this hydrogen, about the hydrogen, many scientists, many chemists worked on the position of hydrogen. That means to give the position of hydrogen in the periodic table, they worked a lot. Understood? Why? Because though it is non-metal, it has given the position above the metals. Carbon, when we compare the carbon is having 6 protons and 6 neutrons, total 1. So mass number is 1. So how to represent the carbon? C6, 1. Yes, all the isotopes are highly radioactive. So we can't go with for normal, for example, if you see the pharmaceutical companies, so when you learn anything, so okay. So when you see the pharmaceutical companies, so whatever we are learning, it should be applicable to our daily life. Am I right? So when we see the pharmaceutical companies, so the efforts, that means any company or anything, what will think economical criteria is the main aspect to obtain any new products, to create a new drug, to identify the new things, to know about the like requirements for the needs of the people, or any cosmetic company, any other companies. The main criteria is what? What is the main criteria? To select the reactants. And economically the reactants cost is not too high. So when we go with the radioactive elements, yes, Kavya, this I have already explained. Neutrons are neutral because there is no effect of the charge, and that's why the nucleus is having positive charge. Why? Because protons are positive. This already I explained. Yes, children? Very good, Kavya. So here, when we go, so economical, this thing for the initiation of any new drug or initiation to identify new product, the main criteria is economical criteria is main. So they won't go directly with the radioactive elements, which are very costly. Understood, children, what I'm saying? They won't go and get the radioactive elements which are very costly. Why? Because whenever any research work is going on in the industrial purpose, it is like a trial and error method. Trial and error method. So initiating with the products, they'll go with the less investment and they'll get a product. No, they identify the humans. Isotopes are identified by humans. Okay, I said all these are natural process. All these are natural process. Will undergo natural process and they themselves forms into isotopes. So the atomic number and the mass number is same for hydrogen. That's why it is unique, though it is a non-metal. It is unique, so it is placed at the top of, very good, at the top of periodic table. And what do you mean by isotopes, children? What do you mean by isotopes? Isotopes are the arc forms of elements. Now we said that only few elements will undergo isotopes. So when we kept the limit, a boundary of 1 to 30 elements, easily we can count. When we go beyond the boundary, like when we compare with 118 elements, then we need to say that more than yes, more than 100 elements shows the isotope property, like shows the forms of isotopes. So isotopes are having same atomic number but different in mass number. When we represent the elements, this is what atomic number. This number won't change. This number won't change. Only the mass number will change. Why the mass number changes? Due to different atomic number. So isotopes clear now, children? The definition of isotopes is the element having same atomic number but different in mass number is known as isotopes. Is called isotopes. Okay, no doubts now. So we have given the examples also with carbon and we have seen about the hydrogen also in the last session. Exceptions for the hydrogen also we have discussed. Yes, if you have any doubts, again we'll be back with the concept. No problem at all.